Welcome and hello. This is a video lesson in the HEC RAS controller. We're going to be updating the Manning's n value in this video. In this lesson, I'm going to show three separate ways to use the HEC RAS controller to programmatically update the Manning's n roughness coefficient in a river reach. So what you see here on the screen is my geometry with my cross-section data. I'm first going to bring up a slide to summarize the three different methods that we're going to be using. These are three separate procedures in the HEC-RAS controller, which we will see demonstrated later in the video. 1, 2, and 3, we have the geometry underscore ratio man subroutine, the geometry underscore set man function, and the geometry underscore set man underscore LCHR function. So the first one is the subroutine, and it's going to update all the existing Manning n value based on a ratio, a multiplier. So we're going to send this subroutine a specific multiplier as well as a range of cross sections within a river reach. Multiple reaches, I believe, is also an option. And then it's going to just multiply the existing Manning's n with the ratio we provided. So if we provided the number 2, it would double Manning's n value. If we provided it a 0.5, it would half all the existing Manning's n values. Ratio number of 1.1 would increase by 10%. That's the idea there. For number 2, this updates Manning's n value specified by a cross-section station. So number 2 and 3 work at just one single cross-section at a time, whereas number 1 is the subroutine, and that can update the Manning's n value for multiple cross-sections. So for instance, on number 2, this is probably the most specific. This is where you can specify the Manning's n value for each individual station elevation point on the cross section. And then lastly, the geometry underscore set man LCHR updates the Manning's n value based on the left overbank, main channel, and right overbank. So you're just going to be setting the values for these two separate functions here, as opposed to multiplying based on the existing Manning's n value. All right, so let's go ahead and get started. As you saw before, what I have is a very simple single river, single reach geometry here with 5 different cross sections. Here is the cross section data. Here is the station elevation data. That's pretty much the same, except the elevation slightly increases with each cross section. Also, what I'm doing to initialize things is set the left overbank to 0.04, the main channel Manning's n value to 0.02, and then the right overbank Manning's n value to 0.04. So that's true for all of our 5 cross sections right here. All right, let's head over to VBA to demonstrate modifying our Manning's n values. So what we're going to do is paste in the code, run it, and then come back here to make manual checks within the graphical user interface of RAS. All right, so here is my Excel file. I'm going to go up to the Developer tab, click on Visual Basic, and then I'm going to double click on that worksheet. So here is my environment where I'm going to write my code. Before we do that, let's go to View, Object Browser, and then select RAS. If you don't see RAS on this list, you're going to want to go to Tools, References, and then make sure you have the checkbox checked next to HEC River Analysis System. And if you don't, you may have to scroll down to wherever that is in the list here. So that's alphabetical. But yeah, anyway, once that's in place and set up, go to View, Object Browser, and then, so I want to filter by RAS, and then scroll down here to my geometry underscore ratio man. Here it is, ratio man, set man, and then set man underscore LCR. So if you click on any of these procedures, it tells you whether it's a function or a subroutine, and as well as the parameters and the data types for each of the 3 procedures that we're going to be looking at in this lesson. I'm going to close that up, and then I'm going to paste in what I have prepared. Boom, there we go. So I'm going to scroll up. Everything that you see here, I just pasted in. I'm going to have 3 separate subroutines here, and they're all going to call a separate set Manning's n procedure. The first one is going to be called change man n underscore 1, and then the other 2 will be called the same thing except underscore 2 and underscore 3. This first one is going to utilize the first one we talked about on the list. This is the geometry underscore ratio man function. This is where we pass it a ratio. It's going to multiply the existing Manning's n values by that ratio, and that's how it's going to get updated. The first step is to create a HEC-RAS object, HEC-RAS controller object, and what I'm doing is sending it to this function right here, which is going to open my project, open project subroutine. And then I'm also going to display the user interface. That's what this show RAS subroutine does. After that, if I scroll down here, here's the actual call to the function, and I have all of my parameters here. The parameters I'm setting up here. So river ID is set to 1. Reach, so we have a reach ID for upstream and downstream. What I'm doing is just going to set the upstream most node, because node ID 1 is what I have set here, so that I'm going to, oh yeah, I only have one reach, so I could actually use the same variable for reach ID, upstream and downstream. And then here is the node for upstream and the node for downstream. In my geometry right here, I'm going to be updating this upstream most cross section at river station 400. So this is river ID 1, reach ID 1, and node ID 1. And that's why you're seeing all these ones right here. We're only going to be multiplying the Manning's n value by 2. So that's why this ratio is set to 2. So I'm going to go ahead and run this. And at the very bottom, I have a message box that's going to pop up. If there's no error, it's going to say it was successful. And if there is an error, it will print out in the message box what that error is. Lastly, I'm going to save the project, but I'm not actually going to close the application because I want to manually check to make sure that those Manning's and roughness values have indeed changed, specifically doubled, because I have a 2 here for my ratio. Okay, I'm going to go ahead and save that. And then I want to close my HEC-RAS because it's going to open up anyway when I run the subroutine. Okay, so just come up to run and then run the subroutine. All right, that's a good sign. I have a message box that says Manning's n values have successfully updated. So I'll click OK, and then I want to open up RAS, open up the geometric data editor, open up the cross sections, and boom, now the Manning's n value have indeed doubled for this cross section right here at River Station 400. This is my node ID 1 because it's at the top of the reach. And you can see we have 0.08, 0.04, 0.08. So if I scroll down to the next cross section at River Station 300, we have the same original values as before, 0.04, 0.02, and 0.04, which is what the Manning's n values should be for the rest of my cross sections. So let's go ahead and do this one more time, but let's demonstrate doubling the existing Manning's n values, not for just this upstream most cross section, but how about for these 3 cross sections, which is 400, 300, and 200 is the river station numbers. So what I need to do here is, let me go ahead and close this up. I'm going to change the downstream node ID from 1 to 3 because the node ID for that cross section at River Station 200 would be 3, and then see, the cross section at River Station 300 would be 2. So it's basically going to be taking the 3 cross sections at the upstream end of the reach to be making updates. Let's go ahead and double that again. So I'm not going to change the ratio. I will save this and then I will run it. So run the subroutine. Okay, so it looks like we have another successful message. That's good. Let's take a look at the geometry data now and cross sections. All right, looks like we've doubled once again here at River Station 400. So now we're up to 0.16 and 0.08. If I scroll downstream to the next cross section, 0.08 and 0.04. So that doubling was successful. And then one more cross section. Again, this has been doubled. But River Station 100, it's original data, and same with River Station 0. These are the original Manning n value that have been preserved. All right, very cool. Next, what we're going to do is demonstrate a second method to programmatically use the HEC-RAS controller to update Manning's n values. So I'm going to be utilizing this cross-section River Station 100. Here you see the data. The existing Manning's n value is 0.04, 0.02, and 0.04. Now you may have some exposure to manually changing the Manning's n value between every single pair of station elevation values in the cross-section. To do that manually, you go up to Options and then Horizontal Variation in Manning's n values. And then what you see here, 0.04, 0.02, and 0.04. This is the exact same equivalent that we had when we saw those numbers printed out in these boxes. But for instance, if I wanted, say, the Manning's N between cross-section station 80 and 100 to be 1, I would just type a 1 in right here, tab off, apply data. Now that has been updated. So you see the 1 up here, which represents the Manning's N roughness coefficient between this point right here and cross-section station 80 and cross-section station 100. Now, I'm not going to do that. I'm going to delete it. But something like this is going to be the end result after we run this change man subroutine, or rather a geometry underscore set man function in the HEC RAS controller. So I'm going to apply data. I'm not going to make that change. In fact, I'm actually going to roll this back so it was exactly as we started. Okay. And apply data. I'm going to close up HEC RAS. And yeah, I guess we can save the changes. I'm going to scroll down to the bottom of my script here and then paste in the second subroutine. This is change man 2, where we're going to be using the geometry underscore set man function. That is right here, geometry underscore set man. Similar subroutine structure as before. We're going to create a HEC RAS controller, open the project, open the GUI. We're going to set our parameters right here. So that's going to involve a little bit different parameters. This time, instead of a river ID as an integer, it's going to be the river name as a string, the reach name as a string. Remember, this is not a range of cross sections. We don't have that option with this function, but it's just going to be one single cross section. So if we did want to change multiple cross section Manning's N values with this function, we'd have to call the function multiple times, send it different river stations. So river station RS right here is a string. That's the third parameter. N count, this refers to the number of cross-section stations that you want to update. This number 7 should be the length of the two arrays. N values and excess stations is what I'm naming them. This is the next two parameters in our function call right down here, N values and excess stations. They are of type single, and then we're going to populate those in just a moment. And then finally an error message, which is a string. So what I'm doing is, this is a more compact and concise way to populate an array. Using the array method in VBA will actually create a variant. So what I'm doing in this function call is to convert the variant array to a single array, or an array of type single, because that's how it's defined up here. And that is the same data type that the HEC RAS controller is expecting. So if you want to get a quick peek at this convert to single array subroutine, I have that written right down here. The only thing that you kind of need to be careful about is that the array that you're assigning and ultimately sending to the HEC RAS controller needs to be starting at 1, 0. So that's why you're going to see a +1 a few places in this function. So that's something to be careful about. And then as for the actual data, I am going to just quite simply increase the Manning's N value by 0.01, starting at 0.01. I understand this is artificial, but I'm just trying to demonstrate how to update Manning's N value. I'm not trying to make the data actually realistic for this video. So 0.01, 0.02, 0.3, and so on. And then the cross-section station values need to correspond with the actual cross-section station values in the cross-section. So this should look familiar: 0, 20, 40, 60, 80, 100, and 120. Okay. So again, what we're doing is updating the Manning's N value at river A, reach 1, river station 100, with these values right here. So let's go ahead and see if this runs. I'm going to click on save and then click within this subroutine, run subroutine. Okay, this looks good. Manning's N value successfully updated. So let's go ahead and open that up now. Geometric data, cross section. I'm going to navigate to river station 100, and boom, here we go. Here are our updated Manning's N values for each of our 20-foot wide sections within the cross section stationing. Up here, you can see the display: 0.01, 0.02, 0.03, 0.04. And this change only occurred right here at river station 100. So if I go down to river station 0, same as original. If I go up to river station 200, this shows the edits that we already made earlier in the lesson. Okay. Also, you may have noticed that it did toggle on this checkbox for horizontal variation in N values without us having to do that. So that was also automatic. All right, the last of the three methods to update Manning's n value programmatically using the HEC RAS controller is to update these values directly: the left overbank Manning's n, main channel Manning's n, and the right overbank Manning's n values. So I'm going to close this up, boom, and let's scroll down a little bit further. I'm going to paste in my paired subroutine, which I'm calling change man n underscore 3. This is going to call the geometry underscore set man. Actually, there's an underscore here as well, LCHR function. So that is right here. And then we have similar parameters, not exactly the same. So as before, we're creating the HEC RAS controller. We're setting up our parameters. We have river A, reach 1. Those are both string. River station now we're going to set to 0, also a string. So that's the downstream most cross section. The only cross section in our geometry that we haven't messed with yet. And then we're setting the Manning's n value for the left overbank, main channel, and the right overbank. So those are the parameters that we're sending to this function. And then lastly, an error message as a blank string variable in case there's an error. If there is an error, it will print out. If not, we'll get another message box to say that the Manning's n values have been successfully updated. Let's go ahead and see if this runs. So if it does, then the Manning's n value at our downstream most cross section at river station 0 should have 0.52, 0.37, and 0.54 for the left, main channel, and okay. So save and click on run and run the subroutine. We have Manning's n successfully updated. That looks good. Let's check out our cross-section data here. And boom, here is the downstream most cross-section, 0.52, 0.37, and 0.54. Those are the updated Manning's n coefficients that we set using the HEC RAS controller. And that sums things up. That's it for this lesson. We talked about 3 different ways to use the HEC RAS controller to update the Manning's n roughness coefficients.